I think it's time to get our bird on, so let's welcome Danny to the stage, our keynote speaker for the Congress.
Great, thank you. Hi. Well, it's great to see so many people here, and many of you have come a long way, and I'm guessing that you're here because you've heard about the famous shorebird populations in Roebuck Bay, so that's what I thought I'd talk about. I'm going to talk about what you're likely to see, but not so much about the actual species you'll see. I'll try and talk about what you'll see the birds doing and why they're doing it, or at least how I interpret that, and hopefully lead on to giving you an understanding of why it's relevant to their conservation. Just some stats down there at the bottom. There's over 150,000 shorebirds in Roebuck Bay. 18 species occur in internationally significant numbers. It makes it pretty much the most important shorebird site in Australia, up there with 80 Mile Beach and the southeast Gulf of Carpentaria. These little things in the corner, those are just the citations of the papers if you want to follow things up sooner. They're looking a bit small, but you're all bird watchers, so you'll have binoculars, so it's okay. My credentials, I've been coming to Broome quite regularly since 1982, mostly for fun. I managed to drag out a PhD on shorebird ecology here from 1997 to 2006, and you'll see a lot of that stuff here in the talk as well. So shorebird basics. You may also have heard shorebirds referred to as waders. English and European people tend to call them waders. Americans tend to call them shorebirds. In Australia, we're bilingual. We use either term. They don't really have a formal taxonomic definition, but they're in the order Chiradiformes. They're leggy. They're mainly in open habitats, especially wetlands and coasts. And here you've got eastern curlew, the world's largest shorebird. It's ejecting a pellet. That's why it's looking a bit strange. And scaled fairly accurately next to it is redneck stint, one of our smallest shorebirds. They're quite diverse in habits and habitats. Some shorebird species are exclusively coastal. They only feed on tidal flats. Some are only found on non-tidal wetlands, and some can move between the two. Some shorebirds are resident, we call them resident. They breed in Australia or New Zealand, and they spend the non-breeding season in Australia or New Zealand, although there's sort of local movements. But the thing that makes shorebirds really spectacular to many people is the amazing migrations they do from one side of the world to the other. And it's a very strange thing when you go out for a walk on the tidal flats of Roebuck Bay or 80 Mile Beach. You'll see thousands of birds out there. And 95% of individuals will be birds that bred on the other side of the world, 10 to 12,000 kilometres away. Just to summarise the lifestyle a bit more, I'll use great knot as an example here. So in their breeding season, which is June, July, they're in the highlands of the Anadyr highlands of Siberia. They're up in the mountains, they're above the Arctic Circle, they're nesting in tundra. They're quite solitary things. You've just got pairs scattered around at loose densities over a very large area. They lay their eggs on the ground very well. That bright breeding plumage that looks so striking here is incredibly well camouflaged when they're sitting on the tundra. They lay a clutch of 4 eggs. The chicks hatch. The chicks feed themselves, but they have to be brooded by the parents for a while because they can't until they can thermoregulate by themselves. All that happens in the space of 6 to 7 weeks, and for the rest of the year they're totally different in character. They're very gregarious, they occur in large flocks. They only feed on tidal flats, so they're totally restricted to the coast. The non-breeding season, where they spend sort of at least 7 months of every year, is here in northern Australia. And to get to Australia and from Australia to the breeding grounds and to get back again, they do amazing migrations with one serious stop in the Yellow Sea. It's hard to take in the scale of migration. So E7 is a great example. This is the world's most famous bar-tailed godwit, and it had a satellite transmitter implanted by a team of scientists from Alaska and New Zealand. And a lot of us knew this was happening. We'd been really anticipating this study. And I remember when it happened, because I was actually here in Broome, and I checked my email, and there was a notification, E7 has just left Alaska, and that's pretty cool. But I had a busy week ahead of me, and I tell this story this way, so you really think about what happens while the shorebird's migrating. So the first day was super low tide, so I spent the day rock pooling, looking for benthos and so on. That was very nice. The next day there was a Lingbia conference in Broome. It's a nasty blue-green algae that's affected some of the mudflats near town. Next day a post-conference field trip. The next day I did a shorebird count. It didn't work, so the next day another shorebird count, hopefully getting it right. The next day went out to Lake Ida. Great day. Bushfire at the end. Took us ages to get back. It was an epic day. Had a rest day the next day, and I checked my email, and E7 was still flying. It hadn't stopped beating its wings once. It had been flying 24 hours a day, hadn't landed because there was nothing to land on. It was over an ocean. No gliding because shorebirds don't do that. It's all powered flight. 8 days later, after taking off from Alaska, it landed in New Zealand, exactly where it had started off a few months before. It's shorebird migration it's hard to take in the scale of it. It's just amazing, the endurance and just the audacity of flying across the biggest ocean of the world. And if you really think about it, you'll never feel sorry for yourself on a long-haul flight again. Some people have compared shorebirds to long-distance high-performance athletes. It's not a bad analogy, so I thought I'd draw it out a bit here. This is Chris Froome, who's won 4 Tours de France, about the sort of most highly trained human athlete you can think of. And we'll compare him against a great knot. So a stage of the Tour de France is 5 hours. Migratory stage for a red knot is 5 days. It's sort of winning. Precision of start dates. Chris Froome knows to the minute when his Tour de France is going to start. Surprisingly, red knots know a lot. It's probably to within 2 or 3 days. The migration period's sort of spread out over a few weeks. But individual birds, research by Phil Batley is showing that they've got these incredibly tight schedules, and the same individual will leave within a couple of days of each other every year. They've got a very good internal clock, so they have they know what they're preparing for. Altitude training. Every climbing cyclist has to do loads of endurance altitude training, so they build up the capacity of their blood to carry oxygen. Shorebirds don't do that. They're at sea level for most of the time. But they actually go to higher altitudes than Chris Froome does. There's a new generation of GPS trackers which are being put on the biggest shorebirds now, and the early results coming through are showing that when they're doing transoceanic crossings, mostly they're a couple of kilometres high, but at times they'll go up to 5.5 kilometres high to exploit cooler temperatures and favourable winds. Navigation aids, not a problem for Chris Froome with race radio and crowds and all that. The knots have to do their own migration. We think they use the sun, stars, a magnetic compass and memory as their cues, but there's lots to find out about how they do it. Going a bit further, Chris Froome is a skinny guy. All the endurance cyclists are, and it's an energetic advantage. You don't have to move so much weight when you're pushing a bike uphill. It would actually be very useful for shorebirds if they could do that too. Flight theory says the lighter you are, the more efficiently you fly. In fact, they can't do that. They're certainly very skinny when they finish a migratory flight. That's what that thing's showing in the top right. But before they take off, they're very fat birds. The reason is energy supplements. No tour cyclists can finish a stage without eating on the way, so they have energy bars. But they don't carry them themselves, they're carried by a team car, but shorebirds have to carry their own stuff, carry their own supply. They carry it in the form of fat, they build up the fat on the non-breeding grounds, and that is why foraging on the non-breeding grounds is so important to them. So, we're in Roebuck Bay. The shorebirds will be here for about 7 months, from about September to March. While they're here, one of their main jobs is to molt their flight feathers. Is this pointer working? Yeah. Anyway, you can see in the wing it's got growing flight feathers. Shorebirds have... Thanks very much.
Take your trying to get it right then. Then I'm next.
Oh well, flight feathers. Shorebirds depend on these flight feathers to fly. They need them for migration. They don't last forever. They have to replace them every year. And the non-breeding grounds is where they do it. It's quite a gradual process. It takes them 4 or 5 months. It's one of the main reasons they're here. Soon as they have done their migration, soon as they've done their flight feather molt, they start to put on. That's when they start to put on heaps of food, and the weight gain is quite dramatic. This is weight gain in a redneck stint because from Victoria, because that was the only graph I happened to have. But they almost double their mass in 6 to 7 weeks before they fly off, and that's when they really need decent food supplies. That's not happening right now, though. Right now, the waders are coming back to Roebuck Bay, and the timing of their arrivals is quite known from a paper by Jimmy Choi and me. We have repeated counts from a lot of the flyway. These are sites where people have counted waders at quite regular intervals during the same season. This is our Roebuck Bay example. These were counts that my dad and I did back in 2007. We did a count a week in Roebuck Bay for a while. And you run a simple statistical model through that, and then you can work out the average time of arrival and so on, which we did for a lot of sites. And with the model, you can predict migration timing. It differs between species, so greater sand plover and eastern curlew, for example, they're early migrants, and nearly all of the greater sands and the eastern curlew of Roebuck Bay have arrived already. At the other end of the scale, godwits and tattlers and stints more come down a bit later. We've only got about half the numbers that will be here later in the season. But those are not the only shorebirds you're going to see in Roebuck Bay. You're going to see, the arriving shorebirds you'll see a variety of plumages. If you're lucky, you might see birds in full breeding plumage. This is curlew sandpiper, but most of them will have started molting. If you're very lucky, you'll see recently arrived juveniles in fresh juvenile plumage. Very pretty, but they mainly start turning up in October. Mostly you're going to see birds that have already got molted into non-breeding plumage, or you'll see birds that are just returning and they've got big blotches of breeding plumage to help you pick them out. But you'll also see quite a lot of birds that never migrated north. They're not in identical plumage to the adults, but it's not easy to pick them apart. But if you look closely, you'll often see sort of glimmers of breeding plumage, not fully developed. So these dark centres to the feathers are broader than they would be in a full non-breeding bird. This one's got these little buffy flecks in the underparts, which kind of foreshadow what the adults have. So you might have fun trying to pick those out. But what are these birds, these that didn't bother to migrate? They're basically young birds, and we know this from banding records. We look at the age of birds captured during the dry season from June to early July, and to make sure we're not getting anything wrong, we confine the analysis initially to birds that were banded when they were very young, so they're really easy to age. And we recapture them, and these were the ages. So you'll see for most species, nearly all of the birds we caught in the dry season were in their first year, but in some species, quite a few birds, 37% of godwits, for example, were in their second year, and a few birds were in their third year, and then there's just a few adults that didn't migrate north because they didn't reach the condition they needed. So you've got lots of young birds that don't bother migrating north in their first year. They stay they get to Australia, and they come down quite slowly on their first southwards migration. They reach Australia, and then they stay here for a full year or more before they start considering migrating north and breeding. We've got other sources of information on how many of these birds there are. The wader banders assign age to birds on the basis of molt characters, and for most species you can do it very well. This is a redneck stint. This is a second year redneck stint, and a wader bander could look at the wing and tell you that. They'd say, look, there's 7 oldish inner primaries, and then there's a molt contrast in the outer 4, it's 4, isn't it? So 6 oldish inner primaries and then 4 newer outer primaries. That's a signature. It tells you that a bird's in its second year. It's just molted the 4 outer primaries to get it through. There's clues like that help you age birds. You also get clues when you compare counts you do in winter with counts you do in summer, because if you consider a bird that doesn't start migrating north until it's 3 years old, your winter counts will have some first year birds and some second year birds. and some third-year birds, so the winter counts will form a higher proportion of the summer counts when everything's here than they will in a bird that starts migrating back when it's very young. So we tied together these lines of evidence to find the age of northwards migration in 37 species of shorebirds that migrate to Australia annually. And basically we came up with some species don't delay maturity at all. Little curlew, swinhoe snipe, oriental pratincoll, long-toed stint, sharp-tailed sandpiper, wood sandpiper, oriental plover. They're ready to go back to the breeding grounds and start breeding before they're a year old. But then there are some species that always delay maturity for 1 year. Common greenshank, pteric sandpiper, grey plover, redneck stint. Curlew sandpiper, broad-billed sandpiper, redneck stint. Then there are some species that delay maturity always delay it for 1 year and sometimes delay it for 2. Black-tailed godwit, ruddy turnstone, grey-tailed tattler. And then there are species that often delay maturity for... I hate it when I make mistakes. That's, of course, a wandering tattler on the bottom right. Then there are species that delay maturity for at least for 2 years, sometimes for 3 years. They've got long delayed maturity. Eastern curlew, bar-tailed godwit, red knot, great knot, whimbrel. So why does the age of first breeding vary? We did a comparative analysis to see whether it was related to various life history indices. So we compared it with breeding productivity. The thinking was that birds that produce more offspring might want to start breeding earlier because normally survival is correlated with fecundity. So if you have high fecundity, you normally have lower survival. So we assessed whether age of first breeding was related to clutch size. We assessed whether it was related to the distance the distance that they migrate, because it's quite different between some shorebird species. This greater sandplovers, for example, would nest somewhere around Mongolia, northern China. And on the other hand, something like red knots from Roebuck Bay would be nesting right up in the New Siberian Islands. So there's some variation there. We thought it might be related to size, because larger species tend to have sort of slower life histories, grow up slower. And we also looked at non-breeding habitat. What came out of it was basically this. Fecundity, no effect. Clutch size doesn't affect the age of first breeding in shorebirds. That's probably because it's capped. Shorebirds never lay more than 4 eggs in a clutch. They could actually incubate more than 4 eggs, but they couldn't bring up more than 4 chicks because shorebird chicks can't keep themselves warm in cool temperatures. So what they do is they run off and feed, and every 10-20 minutes or so they run back to their mum or their dad, and they press the back of their neck against their mum or dad's brood patch. The back of the neck has some blood vessels very close to the surface. There's instant transfer of heat, and that's how they keep alive. But there's only space for 4 backs of necks against every adult shorebird, so that limits their breeding productivity. Distance from breeding grounds didn't have an effect on age of first breeding. That might be because all our data came from Australia, and wherever the birds breed, they're a long way from Australia. So I suspect that if you'd done the same study on birds in Asia, you may have found an effect, but down here, no effect at all. Size does have a modest effect. Bigger species take longer to grow up. That's eastern curlew and redneck stint again. And non-breeding habitat has a very strong effect. Shorebirds of coastal habitats take much longer to mature than shorebirds of non-tidal habitats. So you take long-toed stint, exclusively a bird of freshwater wetlands, doesn't delay maturity, always goes back just before it's a year old. Redneck stint, most of our population is coastal. They always take 2 years to grow up. So why would coastal species take longer to grow up? My theory is it's because young birds don't forage as efficiently as adults, and they may find it harder to fuel on schedule. And 2 things could contribute to that. Firstly, tidal flats are exposed for 12 hours a day. When the tide's high, the shorebirds can't feed. Birds on a freshwater wetland can feed for as long as they like, and they actually do. If you take a spotlight or some night viewing equipment out to a freshwater wetland and watch shorebirds, they're eating through most of the night as well as through a lot of the day. I also think it takes longer to learn how to forage on a tidal flat. And to try and put my case forward, just describe foraging in freshwater wetlands for a shorebird. The big challenge for them is finding wetlands with enough food, because temporary freshwater wetlands that are suitable for shorebirds are normally temporary. So the average prey abundance on freshwater wetlands isn't especially high. The biomass is lower than it is on a tidal flat. But there's pulses when there's lots of food, so the challenge is finding a wetland at the right time. It's also very important to find water of suitable depth, because most shorebirds feed while wading and they've got very specific depth preferences. So redneck stint really likes shallow water, just a film around its toes, 1 to 2 millimetres deep. Sharp-tailed sandpiper, happiest in water that's sort of 1 to 5 centimetres deep. Curlew sandpipers like to forage with their feet wet, the water's preferably 3 to 5 centimetres deep and so on. Every species has got a different preference, but between them they've got all the wetland covered. The simple side of foraging in non-tidal wetlands is the prey. In saline wetlands, very salty ones, the water's too salty for fish and other predators, so there's a few hardy invertebrates that get to incredibly high densities, such as brine shrimp. They're at such high densities that foraging's easy for a shorebird. Freshwater ponds, the diet of freshwater shorebirds almost always turns out to be chironomid larvae, such as this. And they're greatest prey. They're quite nutritious. They're really slow, and they don't burrow much. They're just sort of in this film on the bottom of the wetland. The waders can stir them up with their feet, and they just float around helplessly, and they get eaten. Not only that, they're bright red, so it's not hard for a shorebird to find them. So I don't think there's much skill in actually eating those. On a tidal flat, though, it's different. The benthic fauna in the tidal flat is very diverse. You'll hear more about this from other speakers. And lots of migratory shorebirds are very specialised in coastal habitats. So to take an example, red knots and great knots exclusively eat bivalves, or almost exclusively eat bivalves. So these are clams, mussels, that sort of thing, 2 shells. They find them buried in the mud, they pull them out, they swallow them whole. If you're really, really close, you can hear a crunch as they squash them in the gizzard. And the gizzard is one of the things that's specialised for that lifestyle. A red knot gizzard is very enlarged, so same size as the gizzard of an oyster catcher, although oyster catchers also eat bivalves, but they take them out of the shell first. But a gizzard has the same size. A red knot has a gizzard the same size as an oyster catcher, just so it can deal with prey. They can actually manipulate the size of the gizzard, so if they have some soft-shelled prey, their gizzard gets small, but if they get into a place where the only bivalves are hard-shelled, they very quickly build their gizzard size up. More specialisations, the bill tip is packed with these sensory pits, and the sensory pits are packed with Herp's corpuscles, very specialised nerve receptors which detect pressure differentials. And red knots use this quite cleverly. They tap the mud with their bill, it sends out pressure waves, which go out in all directions. The pressure waves go through the pore water in the mud. If the pressure waves hit a hard object, the signal's reflected back. It's a bit like echolocation. And the knots pick up that signal with their bill tip. And in experiments, they can find a buried stone from 5 centimetres. So it's great for finding buried prey at fairly low densities. But there's a lot of buried stuff in a tidal flat. Some of what they'll find there is what they really want. So shellfish in bivalves in the genus Telina, relatively thin shells, lots of meat, they love those. In Roebuck Bay, the best shorebird prey for knots is Siliqua modiate. Siliqua, it's got a very thin shell, it's packed with meat, it's a very lively sort of bivalve. That's good food, but then you've got lots of bivalves they can't eat. So Anodara, lots of the cockles here are just too big for a great knot to swallow, and some are very heavily armoured with spikes and things so that shorebirds don't eat them. So you've got all that sort of stuff in the mudflat that they can't eat, and of course every shellfish dies, it leaves its shell there, there's loads of buried objects that are totally inedible. I reckon it must take some skill to learn how to use that information they're getting from the bill tip. And if you look at the intake rates, this is the energy that birds take in per second when they're foraging. Adults have a high intake rate, first-year birds have a low intake rate, second-year birds are sort of in between. But very conveniently, not sometimes switch from foraging by touch for bivalves to foraging by sight for amphipods and especially shrimps. If there's shrimps around, they go crazy. They have to chase them. And the foraging success of first-year birds and adults when feeding by sight for shrimps is pretty much the same. But when they're feeding by touch and hunting bivalves, adults are very good at it. Young birds are rubbish. They're really quite clumsy. They quite often pick up things they can't eat and they throw them away. So that's my case for arguing that shorebirds find it harder to learn how to feed on a tidal flat. As for where they feed on the tidal flat, this red dotted line indicates where the tidal flats extend to roughly on a spring low tide. And you have a walk on them, which I thoroughly recommend on your visit to Broome. Shorebirds might look very uniform when you look at them from the edge, but when you start walking over them, they're not not in the slightest bit uniform. In Roebuck Bay, for example, you'll find lovely coarse sand flats at the Broome end of the bay and also towards Bush Point. The deeper you go into the bay, the muddier the sediments get, and walking around in this part of the world is not good fun at all. But I've done quite a bit of it because